Hello, everyone. I'll be taking you through the exploratory data analysis for heart disease detection. I'm with my groupmates here, Kalima Alan, Namtosi Diana, and me, myself, Kabma Hamza. I'll take you through a brief introduction. What EDA is. EDA is the initial phase of data analysis aimed at data processing. We get the data, and then after data collection, we have to get to pass through an EDA so as to make sure the data we have can be well prepared to be used as a data set in our machine learning model. The objective of the EDA is identifying potential data quality issues such as missing values, as we'll see in the future on that we found some missing values in our data set that we chose. The other objective is to gain insightful findings from the heart disease dataset to help us in the subsequent steps in the machine learning model development. Then the other objective is understanding the distribution, the variability, and the relationships within the dataset. As we will see, there are going to be very many features in our dataset, and some of them we're going to link some of these features to the other and how they help us in the dataset. We were able to review different datasets, which were 3, but we chose one, which is Framingham Heart Study dataset. It has 4,240 records, each representing a unique patient. It has 15 features used to describe each patient. And then at the end, one of the features is the 10-year risk of future coronary heart disease, which will help us in the machine learning model. Why choose this data set? It has many data points. As I said, there were 4,240. It has no duplicates. It has many features. Has a vast age range, which means it's slightly balanced. Then it also has a slightly balanced gender percentage, 57.08 female and the others male, and then has less irrelevant features. Here below are the attributes and features for the dataset. There is age, there is sex, there is education, current smoker, cigarettes per day, blood pressure, cholesterol, glucose, BMI, heart rate, if the person has diabetes, is at risk of diabetes or not, prevalent stroke, hypertension, and family history. Yeah, so my colleague will take it from there on in.
Hello, my name is Namtosi Diana, and I will take on from here. I'll talk about the data cleaning. So data cleaning is after we have gotten your data, you have collected the data, before we use it in our model, it has to be cleaned. It had errors, outliers, it has noise. Some data sets can be having like the duplicates, missing values. So to clean that data, we have to do the EDA. So data cleaning, it removes those anomalies in the raw data before you use it. So like here in the diagram here, it solves the issues of incomplete data, data inconsistencies, incorrect data, and duplicate data. So here in the diagram on the right, import the data, then you standardize it. Duplication, like if it was duplicate, remove the duplicated values, then you verify it. Then after that, you export your data and use it in your model. So what we found in our data set, the one we are choosing, yes, we chose 3 data sets, but we are using only what? We chose this one that we have documented about. So this one, why we chose this data set is that it has no duplicates, and it had missing values, but these values, how we dealt with them is that since it's a health sector, we didn't fill in the missing values. We like, as we shall show in the code the other side, we delete, we did what? We removed the fields that we have in the missing values. For example, education. Education really doesn't really affect someone, like doesn't contribute to someone having heart disease. So it had no like outliers, and then it really had no much inconsistencies. That's why we chose this data set. And then these are our visualizations. So for the correlations here, I'll start from the key here on the right. When the color is darker or green, it means that's the positive correlation. For example, here, if I check here, if I'm taking this of diabetes, it's a positive correlation that if someone has diabetes, then their glucose levels are high. And then when I come here, for example, if I take this one, it's a negative correlation. If someone is a smoker, then their BMI is it is definitely lower. Then this is how our data is. We got it in that females are more than males, and then from the age, more people are got from the age of 40 to 50. Then here was the smoking status, someone either smoking or not, and we find that the ones who are not smoking are more than those that smoke. Then this is all it. And these are the bar graph showing the count of sex and female or male and females. Yeah. Then the rest will be talked about in the code, the other side, since we don't have time. Thank you. Then for the insights about the correlation, I've already explained it in the heat map diagram. Thank you.
Hello everyone, this is Kalema Alan, and I'm going to talk about the quality and depth of the data analysis. I'm going to refer us to the code of what we did. During the EDA, we used the Google Colab as our notebook, and this is what we carried out. We imported this to be used. We specified the path to the data set. We had uploaded, we read it, and the shape was 4240. Those are the number of rows, and the number of columns were 16. And this is the head of, we're trying to see how it's structured. So this is the head. It shows the male. Male is either positive 1 or 0, 0 implying you're female. And other features as we're seeing here. This is the tail. So we went down here and we got the data types. There were ints and floats. We plotted a graph to show the variations of the different features with their values. For example, male to female, this is the graph, 0 showing the number of females and number of males, the age as you're seeing it here, and all these graphs are shared as my colleague has mentioned. And we went down here, we got the info. The reason why we got the info, we're trying to see the number of fields that might be missing certain values, since the total number was 4 to 40. So we also hit on we described the data of which we're showing the mean, the standard variation, the 70th percentile, the 50th percentile, and all that. So down here, we were looking for the number of features that have missing values, and the features were 7. And we also hint on the duplicates. We're looking for duplicate values here, and it showed all false in every aspect. The set of missingness, we're showing the percentage of which feature has the highest number of things that are missing. At this point, we dropped the feature for education because it had a second number of it was the second highest missingness feature, and it wasn't really correlating with what our data was to provide. So we dropped that. The number of rows that were missing were 489. And this we're trying to analyze whether we should drop them or not. And according to our analysis, we decided to drop each that was missing because it wouldn't be ethical to fill in the missing values. So we remained with 3751, and that's the data we worked on, and 15 columns because we had deleted some. And this graph was showing the number of, if we're showing whether all the data is filled in, it's a PLT show. Went down, checked for duplicates. We didn't have duplicates. And this was showing the percentage of the the percentage of people who have, this graph shows the people who have the disease and those who don't. And as you go down here, this is the male, female. My colleague talked about that. And yes, this is the cleaning procedure as we did it in our. In conclusion, effective EDA lays the foundation for successful machine learning applications, ensuring that the data is appropriately prepared and insights are leveraged to build a robust predictive model for the heart disease detection. So this is, and these were our citations of the work we presented. Thanks for watching. This is group 3.